So the next thing is a combination of relevant technologies. Now, I think this is going to be of much more interest to the people in the packaging conference than to you guys, but I'll do it all the same. This is a bit outline. So a Git pack file is actually a form of packaging, just like a zip archive, to answer Steve's question, is a form of packaging. A zip archive is a way of packaging files together. And a Git pack file is a bit similar, but Git has some magic properties. Namely, it deduplicates. If two files are the same, it only keeps one copy. So if you have 20 versions of a project, and each project has got 100 files, and every so often one of the files changes, Git might only need to keep copies of 150 files. And it's actually even better than that, because if two files are nearly identical, which they are when you sort of fix a typo, it only stores the difference. So that's a way of packaging information. And a Git pack file is a way of saying, here's a bunch of stuff that your Git system can use. And in Git, everything has a secure hash. So in a sense, a Git pack file doesn't have a root. It just has the answers to a bunch of secure hashes. Now, I told you that a portable tech document had the actual files the author wrote, together with the resources needed as Git hashes. So if you've got the right Git pack files available to you, you can resolve those resources. That's how the Git is coming in. So you just have one copy of everything that you might need, and the Git and the portable tech document will tell you what things you need to get. So this brings us on to the next thing, which is a Git Bomb, which is produced by somebody called Katie, whose second name I've forgotten. It's a marvelous device. It's a Git repository that occupies less than a megabyte. But when you unpack it, it occupies 60 gigabytes. And it's a whole bunch of chains leading down to a file. And every file says, ha, 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 laugh. So this is sometimes called a billion laughs, and it exists in other languages. And the way it works is very simple. You just take 0, 1, 2, 3, 7 into the path 0/1 times 3 times 7, and then at 7 you put a laugh. And so many things are identical that Git hasn't got to store very much at all. So that's what a Git bomb is. And then use fuse to defuse Git bomb. I might wonder what that means. Well, the capital letter fuse is a file system in user space, which is a posh word for saying, take some information and present it to the user, have the computer present it as if it were a real file system. So this allows you to make fake file systems that are indistinguishable from real ones. And you can have a Git bomb, and if you mount it using a file system in user space, it still only occupies a megabyte, even though when you traverse it, it occupies 60 gigabytes. So it's an extreme form of compression, if you like. There's something called SquashFS, which is much more widely used and doesn't rely on a fuse system that hasn't been written yet, that does similar things. That's used in your home router, for example, for storing and mounting all the files that the router needs. And there's a final technology, which is the XML Catalog, or the URI resolver, as it's used in the XSLT transformation language. And the basic feature of that is that the document gives a label for what's required, and the system resolves the label. So it's quite common in XML to have a URL as the label, and the resolver, instead of fetching the thing from the internet, says, no, I'm not going to fetch it from the internet because I've already got it. So I'll give it here. And the resolver is important, because if we write our systems using resolvers to get files, then we have much more flexibility as to how we actually get the files in a particular situation than if we use the file system. Because the resolver could get it from the file system or could get it from a Git repository. Excellent. Any questions? Okay, so the final thing, which was suggested by one of the reviews of this talk, is what I'm doing specific to the target ecosystem, which is tech? I say it's not. In HTML, when you get a web page, along with the text of the page, you'll get some cascading style sheets and some JavaScript. And download time is really important in the web because people get bored in less than half a second. And so much effort is made to ensure that the web page downloads only the CSS and JavaScript it needs. Now, what I didn't mention earlier, which I should have done, is that part of this whole framework of a portable tech document, which I haven't covered in my slides, is that when you're sent a portable tech document, you get a list of the things needed to typeset it. And getting hold of those things is a bit like downloading a web page. So the system, and Git will do this for you, will say, oh, these are the things we got, these are the things we need. We'll ask so-and-so if they've got them. And if you have a tech document and it only needs 20 megabytes of material and you've got 10 of them already, you only need to download the remaining 10. And if you've already got everything, you don't need to download anything at all. So the problem of the big download is solved as long as we know exactly what the document needs. And that's a social and cultural problem as much as anything else in the tech system. Another area is version control for servers. Servers have configuration files. And I believe there's an experimental development of an operating system where the whole state of the operating system is effectively under version control. And if you had a Git repository mounted as a file system, that would work well for you. And similarly for security, don't write to a mounted file system. If you have a server that must be secure, don't install anything to a mounted file system, because if an intruder gets in and gets administrative permissions, they can also write to that file system and you've no idea what happens. All you know is that somebody's got in and changed something somewhere perhaps. And that's why security breaches cause websites to be down for so long. Instead, mount a secure hash from a read-only file system. So if you can ensure that your file system is read-only, then the intruder can't do anything until they get to that read-only file system. And that's a much harder business. And you can guarantee that you're getting the right stuff by making sure that you're loading from the right secure hash. So it all becomes much safer and easier. So what next? Well, thank you for listening. And at the moment, I'm exploring fundamentals. I'm trying to see what things work, see what things don't work, see what needs to be done. And the purpose of this is so that I can get some toy examples working next spring. What I haven't done yet, but must do before the talk, is set up a project repository and a mailing list so people can join up for news and see what's going on when they want to. So there we go. There's my talk. Before I stop sharing, do we want to look at any of the slides? Again? Okay, I'll stop the share. There we go. We'll have a conversation. I expect Nelson will want to come in first.
Yes, well, I do have a question. Running software normally requires, on any operating system, communication of information about where to look for files to be run. In Unix, this is the path variable. Microsoft Windows has a similar one as well, although they store it in a repository rather than having it as an obvious, easily modifiable variable. how do you handle this when you're dynamically, for example, let's pick your collaborator who's never had tech on his system before, downloads the minimal repository that provides the files he needs to actually run tech in your document. But when he does that, somehow there has to be a path set, and possibly multiple paths, because tech has many different environment variables. Where is that happening?
Okay, so the short answer is everything will function as before if we want it to, with a number of small changes. The long answer is something like this. Everything in Git has a secure hash. So you can have a whole directory tree as a secure hash. And if you have another directory tree that is almost identical, you'll have a different secure hash, but you won't have any massive duplication of data. So that's why the Git Bomb is relevant, because the Git Bomb consists entirely of duplication of data. And that's why it can be so small and expand to be so big. And if you've got the 5 gigabyte tech live, and you've got 20 or 30 different versions of it, you've just built yourself a Git Bomb. So the only thing that the system has to provide and deal with that is not already dealt with is the secure hash where everything is stored. What is the secure hash for the computation? And that having that secure hash is absolutely vital for sharing that computation with somebody else, because you simply share that secure hash and then Git will be able to resolve everything as long as it can ask the questions of the right repositories. You can't unpackage a secure hash except by accessing a repository that's got a copy of it. So that's why the secure hash is so important. So typically you'd have a normal text system, a normal text system, except there'll be one more environment variable, if you like, which is the secure hash to use. So if you simply add a secure hash saying, this is my tech typesetting secure hash, that will work out fine. And you can use indirection. So you can say that this name corresponds to this secure hash. So you don't actually have to remember these enormous long sequences of numbers. So that's how it works. It would work sort of the same way as before. And the configuration changes required to use different versions of tech would then all be consolidated into one. It will be more straightforward. And the executables can also be stored, which is something the current text system is not particularly good at, is saying, I want last week's version of the executable because something changed this week, without, what's the word? It's a global. There's the problem with globals is everybody wants to change it and pretend that it's their own and nobody else is changing it. So one of the advantages of this is that everybody, so to speak, has their own global, but you don't need to have everybody to have their their own 5 gigabytes. And what's more, you can share the globals straightforwardly. So the Git version control system allows two developers to know that they've both got exactly the same tree of files and to bring the trees of files into synchronization. And one of the benefits of portable tech documents is that when implemented, they will provide exactly that feature. And another feature is archiving a portable tech document. It should be straightforward because the only thing you do, the portable tech document is already archived as long as you can guarantee that the secure hash is resolved. And that's, if you like, a much easier business because most of the secure hashes will be stored at many, many places. And you just have to make sure that the ones that are peculiar to you are resolved. Have I more or less answered your question, Nelson?
One related one then is that your new collaborator who's never seen tech before, he's got this down. He's modified one paragraph in your collaborative document. He now wants to communicate that back to you. How does that happen when he may not know anything about Git?
Well, we'll have to make Git easier to use, won't we? Or it simply happens without him knowing it. Git is just a computer program that can be used by humans, and it can also be used by scripts and command lines. So you can make it that every time you save a file or every time you run tech, an upload is made to the Git repository. And so you get a portable tech document every time you run tech. And the portable tech document is stored in your repository. And then all you have to do is tell the person which one of the many versions you've got is the one that counts. And I suppose the sensible way to do that is to put the secure hash on the front page of the document. You seem happy with that answer, Nelson.
I'm happy that Nelson is happy, even though I don't understand anything about what you're describing.